So for this next section, it's going to be highly interactive. There's going to be a lot of needs for paying attention to certain details, and I'd like to provide you with a few points of guidance, if I could. Okay, item 1. We're going to be undertaking an exercise which is going to be inside of AnyLogic, and if you get lost there's going to be a set of steps we go through, and if you get lost in any of the steps, please be encouraged to ask the person next to you. Look over what they're doing, ask them if you've missed a step, okay? Secondly, absent that, if you could raise your hand so the TAs could get to you. But there's a third component of it that may sound like a minor issue, but it's going to be a major factor in how smoothly you can progress. And this factor is going to be the fact that there's going to be a way for AnyLogic to help you with some of the steps directly through a technique called auto-completion. Okay, it's going to fill out the name of a variable, for example, for you. And we're going to teach you how to do that in just a minute here, and I'm going to ask you to be very careful about trying to use that as much as possible, because it'll spare you maybe 80% of the problems you would otherwise encounter, okay, based on our experience in other boot camps. The final thing is, if any of you get stuck at any point, I'm going to post on an ongoing basis my model to that model's built-in class area of the website, where you should be able to obtain it to get the very latest model that I've created. Okay, and so don't fear that you're left behind. We'll make sure that you can be brought along. You can go download that. I'll let you know when I post mine. Okay, I'll be pausing a little bit, let you catch up, and I'll post mine up there. Okay. During the break, I contemplated the situation, and I selected a model that I'd like to build together with you. Okay. We've about 2 hours. I'm going to do it in stages. We'll see how far we can get since this is our first model together. Ladies and gentlemen, I'd like you to go to AnyLogic, and I'd like you to close any models that you have open. How do you do that? You can do File, Close, or Close All here. Okay. Okay. Here we've closed off those models. Now we're going to go where you have never perhaps gone before. Okay. File, New, Model.
You don't have Captain Cook this time.
Sorry?
You don't have Captain Cook.
Okay. Yeah, exactly. Still alive. Smoking and heart disease. So how did I do that? I went File, New, Model, Smoking and heart disease. But I'm doing something, you notice, I already have one, so Sydney. You don't have to write that, Sydney, but I will. And ladies and gentlemen, you'll notice there's something else we need to specify. And we need to be a little bit careful about it. It behooves us to be careful about it. So there's a thing called model time units there, okay? And I'd like this to be set to years. AnyLogic's model of time is continuous one. Things happen as quickly as necessary to get the job done. Sometimes your model may have events occurring in very quick succession. Maybe it's events associated with an outbreak. And other times things may have longer times between them. AnyLogic doesn't force you to adopt a single tick or time step for it, which actually, and the result is, for the continuous time, it's actually much easier to capture certain factors. You don't have to worry, you're doing a month at a time, which thing within the month occurred first, death, or finishing of some other endpoint. It just things happen at the time they naturally do. So I'd like to suggest select years. This is just a yardstick by which we measure time. It doesn't mean the model is leaping forward year by year. It may be going forward days at a time at some points, months at a time. This is just the yardstick, the meter stick by which we judge how long, what does one mean in terms of length of time? Does it mean a year? Does it mean a month? A day? So what this is telling us is a length of one in time 1 versus time 2, the difference is 1 year. Okay? 1 year. Okay, ladies and gentlemen, let us now say finish. Okay. So when I do that, you should see over in the projects window, when you do that, you should see over in the projects window something like this. Do you see that? Yeah? Okay, good. So we have the beginning, ladies and gentlemen, of our first model. I'd like to now add some features to this model to allow us to capture some features of interest. So the first thing I'm going to do is I'm going to go to the palette. Actually, even before that, I think what I'll do is I'll go right-click on the model, say New Agent Type. We can actually do this from the palette, but I actually prefer to do it directly from here. New Agent Type. Do you see that? Yeah? So right-click on the model as a whole. Be careful what you're clicking on here, because if you click on different portions, it'll give you different options. So I'm right-clicking here. I'm saying New Agent Type, and I'd like you to do person with a capital P. Ladies and gentlemen, any logic being based on programming like called Java is case sensitive. It makes a difference whether you capitalize things. And actually, there's conventions. If you see something with a capital P, it's indicating a whole class or sort of type of thing. Capital P, this is going to describe, we're going to insert something into our model that's going to describe personhood with respect to the model, what personness is, what it means to be a person with respect to this model. So it's a capital P-E-R-S-O-N, okay? Capital P. And I'm going to do finish. There we go. Okay, person. You'll notice person has been added to the model, and person is in fact showing here. Do you see that? Okay. Ladies and gentlemen, I would like to provide person with a visual depiction. And to make it as simple as possible, because we're going to have to watch our time, I'm going to place a little circle here. Okay? Later we'll enjoy recourse to more realistic representations. Right now it's a circle. How did I do that? I dragged in from the palette, and I dragged it, and you notice I put it right where this place is. Let me do that again so that you can see this. I dragged in like this, and I put it there. Do you see that? Now, there's two ways you can adjust the size of that circle. One is you can kind of frob it this way. So you can engage in frobbing behavior by moving it around. See that? You too, ladies and gentlemen, can learn to frob. But there's another way which is more dependable than that frobbing, and that is you can just click on it. And by virtue of clicking on it, you'll notice over here in the properties it shows features. And you can actually scroll down and set the radius. Do you see it says radius? Do you see that there? Do you see that there thing? Yeah? Okay. So I'm going to say radius of 10. There it is. So that's going to be a representation of a person. Do you see that? Yeah? Okay, who needs TA help? Okay, TAs, TAs need to be deployed in Sector 1. Okay? Okay, we still have an active case. Okay? Okay, so 10. 10. So if we click on this thing and we go look in properties and you scroll down, there'll be a thing called radius, and I filled in 10. Okay. Okay, we have high duty cycle right now. Okay. Okay, wind chill, other case in sector 1. Zone A. Okay. Okay. Ladies and gentlemen, who else needs TA help? Okay. Ladies and gentlemen, so do you have this circle? I clicked on the circle. By virtue of clicking on it, shows in properties. I went down to radius and I set 10. Good or not? Okay, good. Okay, excellent. Ladies and gentlemen, now what I'd like to do, I've described the theory of personhood. And the theory of personhood here is particularly minimal. An agent has a face upon the world. It has a circular visage. But we don't even have a population of people yet. If we go over to Maine, we have a theory of personhood, but there's not one person who yet strides upon this firmament. So let's go add a person into here, okay? We're going to add a population of people. We've articulated a theory of personhood, but there's no persons yet. So we're going to go to projects here, and we are going to go to Maine. Make sure you're in Maine. One of the biggest challenges of any logic is being clear about what's being shown right now, so when you drag something in, you drag it into the right thing. Maine should be shown, right? Remember the main. So let's drag in person to main. How did I do that? Oops. Drag in person to main. And you'll notice when it drags it in, it creates something like this. And I am actually going to type population. This is going to be an oft-repeated action, ladies and gentlemen. At first, it may seem overwhelming. But you'll find there's certain actions that you do again and again and again. They're standard. These core conserved mechanisms carry over from model to model to model.
This population doesn't have to be in capital P?
Nope, because it's not delineating a theory of sort of large class. It's a particular population. Okay, so it's a good call, but it doesn't have to be in capital P. Okay, it's not a whole sort of class of possible things. It's a particular population. And this population, ladies and gentlemen, it's actually not a population yet. Its name belies its reality. In order to turn it to a population, you notice that it's selected here, therefore it's displayed here. I'd like to select population of agents. Do you see that? Population of agents. Comfortable or not? Okay, good. I appreciate your vote. So ladies and gentlemen, having done that, you'll notice something occurred up here in the upper left of Maine. What do you see? Yeah, it's the visage of the agent superimposed there. This is going to show that, okay, this could be a population of people shown in this area. Okay? Okay, ladies and gentlemen, without prejudice, let's run this model. May we run it? Does anyone object? Let's run it. Right click on, so this is an experiment. X marks the spot of an experiment without a dot. So this is an experiment, ladies and gentlemen. You right click on it and you select run. Okay? And now we'll run it, and you'll see something that lacks remarkable inspiration or dynamics, but it's running. And in fact, you'll see that there's this thing called population there, and if you click on population, you'll see there's 100 people arrayed before us. Moreover, if you go to Maine and you go down Maine to population, you'll see that there's 100 people in succession there. But these 100 people are in a difficult position, a crowded position. They're all atop each other here. Okay? That's why they're all stacked. Stacked up, and so it looks like one. Okay? So ladies and gentlemen, here we have a population. It's a population of 100 right now, because we indicated that's what the size should be. And they have a depiction. We're going to start lending particulars to this population. But the first thing we're going to do, ladies and gentlemen, is actually we're going to lend them a type of heterogeneity that befits their individual character. We're going to lay them out at a different place on the screen. And we'll return to this feature. We're going to give them a location. They deserve a home. Okay? So let's go to population. And we go to population, ladies and gentlemen. Oops, didn't mean to double click on it. Here, population, I'm selecting. Ladies and gentlemen, person with a capital P, that represents a theory of personhood. This is a particular population of people. If any of you are having trouble, make sure it's a population of agents of size 100. By default, it's a single agent, but it should be a population. Make sure that's lined up. Okay, ladies and gentlemen, underneath this area for properties, you'll find several characteristics. This is a population of people of certain characteristics, and one of the characteristics will be their location. So within the AnyLogic interface, you'll have these expandable, I think they're sometimes called accordion areas. So we can click on this, and you notice we'll have some options. We can place the agent in a specified location, a specified point, or in a certain node of within the system. For now, we're going to say in the specified point. We're going to lay them out at a particular position. Okay? Okay. Okay. So, ladies and gentlemen, here we're going to go. Oops. Okay. We're going to go and we're going to give them an X location and a Y location, which will place them visually. So for the X location, I'm going to say that they're uniformly drawn from a location between 0 and 500. So I'm going to type here uniform between 0.0 and 500.0. What this means is when each person is getting assigned a location, it's going to draw a value from this distribution and give that to them. This is kind of a formula by which each person's X is going to be figured out for each person's Y location. And I'm going to copy that same thing, ladies and gentlemen, down to the Y area. Okay? Just like that. Do you see that? Okay, ladies and gentlemen, I told you that I'm going to try to teach you skills which will prevent big problems. And I'd like to start here. So I'm going to actually get rid of that, and I'm going to say this. And I'm going to start typing, and I'm going to go here, and I'm going to press Control Space on my computer. It's on Windows and Linux, for that matter. That's how you do it. You do Control Space, and it will give you a choice. Notice it knows about these things. There's Union, Unicode, Uniform. And as you type Uniform, it actually will show you a smaller and smaller set. I'm going to select Uniform here, and I'll select one of those. Okay, it'll actually fill it out for us, and that's how we can do that. Now on a Mac, it's Winchell. On a Mac, autocomplete is what? Option space or
by default Alt.
Alt space?
Yeah, an option. Which is option and space.
Okay, option space. Okay, thank you very much. So, ladies and gentlemen, we're going to come back to that autocomplete. I just want you getting started on it. So, the next thing I want you to do is a lesson. Also, I'd like you to go up here, and you'll notice next to the big green button, there's a thing that says Build Model. Do you see or not? I'd like you to press that. And you'll notice down here it should say Build Completed Successfully. Do you see that? Yeah? Okay. That means AnyLogic understands what you're trying to say. It thinks it understands how you phrased it. Okay? And it's ready to go. So I'd like you to now run this model by right-clicking on simulation and do run. And what you will see now is a different picture. What do we see before us? Ladies and gentlemen, what scene lies before us? Yeah, so what are these dots? Those are people, indeed. So if we go down to the level of population, each of these people is still just a dot there, but each of those dots is associated with a different person. They're just scattered around the space, and there's 100 of them, okay? Yeah?
It's exactly the same between two different computers.
Yeah, yes. Well, there's a reason why, and I'll tell you a principle to which you'll come back. I'm going through these principles, and that's a great segue to the next one. For the principle here is, ladies and gentlemen, when you run a simulation, you have two big options with respect to reproducibility of that simulation. One option is you want it to run it so that every time you get the same thing, again and again. The second option, you actually want it to randomize it every time so you see something different. And you want both, recourse to both. Sometimes you want to have it so you can reproduce that figure exactly for a paper. It's that exact scenario. Other times, by contrast, you want to explore different features of the situation with different happenstance. So if you go to this experiment and you go down within properties for that experiment, you'll notice that you can choose here what are called a seed. This basically means when it has to roll a dice for where people go in that space, either will it roll them in exactly the same way or will it do it different each time. I'm going to choose random seed. And now, if I run it once, I'll see one pattern. You'll notice this one that's overlapping with N up here, but the remainder of the letters are clear. I'll run it again, and here we go. And now we see a different configuration. Okay? Ladies and gentlemen, here paying attention to this setting is important because it will dictate whether you see exactly the same results each time or you see different results. Okay? Who needs TA help? Okay? TA deployment. Okay? Others? Great. A full complement of TAs. Excellent. Okay, ladies and gentlemen. Right now we've lent some differences between these people, but those differences are reducible purely to location. And now the plot will thicken, and it will get ever thicker for the rest of the day. Okay? Ladies and gentlemen, I'd like you to go, and we're going to add in some features of these agents. Okay? We're going to add some features.
Can I please ask something?
Yes.
How do I know that it has finished running? Because like at the bottom there is date and then it keeps changing everything down there.
Sure. So it's a good question. So if I click, you'll notice that it's changing here, right? And I could run it, and in fact, it will go on to time infinity, where it says finished. I use this control to do that. I use this control up here, where I said basically run as fast as possible. Okay, this so-called toggle is real-time mode, where I versus virtual time. In one of those modes, basically, I'm throttling its speed for convenience. I'm saying I want to see what's going on. And the other one, it runs as fast as it can, flat out, as we say. Okay? Perhaps even like a lizard drinking. It's just running as fast as possible. Okay? There we go. And here, it's run it out as fast as possible. But here, this is an intriguing possibility. It's run till time infinity. AnyLogic just knows there's nothing more to do. Nothing's going to change from now on. So it labels it time infinity. In general, in your question, if you go over to simulation, just above randomness, you'll see there's an area called model time in the experiment. So on a per experiment basis, we can actually specify the stop time. We could say never stop at specified time or specified date. So we could specify, for example, stop after 100, time unit is years, as indicated down here, and it will stop after 100 years. Or maybe in a different experiment, we wish it to run to just 50 years, and we could run it out to that, okay? Here's 100 years. So we can actually set on a per experiment basis, just like we could set randomness properties, we can further set the time at which it will stop, and as we'll soon see, we can specify the assumptions about the model, okay? Yeah, thank you very much. Other questions this far? Okay, ladies and gentlemen. So now we will press our query further, okay? Ladies and gentlemen, I'd like you to go to person. Repair to person. And from the palette, we will go and draw a selection. This is the first time we've used the palette to achieve our ends. So if we go to the palette, we'll see there's actually several sub-palettes. These sub-palettes span from analysis tools to system dynamics modeling tools, tools more related to agent-based modeling. Oh, presentation tools. We actually did draw from there before. So it's only the second time we've used the palette. Ladies and gentlemen, I'd like you to go to the agent palette, which was recommended by a red figure in the form of Da Vinci's Measure of Man. It's kind of a figure of a man with outstretched legs and arms. Do you see that?
Yeah.
Okay. There, if you view that the palette associated with that Da Vincian icon, there's an area called parameter. Do you see that? I'd like you to drag that into person. And I'd like you to type for its name. It'll prompt you for its name in blue. And where that lies, I'd like you to type age. Do you see that? Who needs TA help? TA help? No? Okay. So we've just added to our theory of personhood the fact that every person within this population has an age. Personness with respect to the model now includes each person has an age. Our theory of personhood consists of a visual representation and an age. Okay? Now, you'll notice there's a default value there. And I could put something there, but it's important to be clear what that is and what that isn't. It's not an initial value of it. It's just if you don't specify it elsewhere, this is the value to use. We'll see two places soon enough. One of them before the day is out. Nay, before these 5 minutes are out. We'll see another place we can specify it. Okay? So the default value, I'll put 20, but we'll see that again momentarily. Ladies and gentlemen, default value. I'd like you now to go to Repair to Main, and I'd like you to click on Population. Ladies and gentlemen, a population, it consists of a specific subpopulation of these agents. So you might have one population for the city of Melbourne, another for the city of Sydney. Okay? And they're all persons. They all share the people in both those cities share the characteristics of personhood, but they differ in their particulars, their age distribution, perhaps the sex distribution, the distribution of different backgrounds or incomes. And that's what populations are associated with. Each population is not a different theory of personhood. No, they share that, the type of the underlying agent here. If they're both populations of persons, they're both delineated by a theory of personhood, but they differ in their particulars. So for this population, we have 100 people, and each of them, you'll notice it says 20. Whence did that 20 come? Well, that was what we gave as the default. So let's type something else. Let's perhaps we'll draw from a distribution. What do you think? So we could draw from a built-in distribution if we wanted to. We, after all, know about uniform. So start typing uni, control space. There's our goal, uniform. I just hit enter and it filled it out. And I'm going to do uniform between 0 and 100, okay? But soon enough, we will go beyond that. You ready? Okay. Ladies and gentlemen, build early, build often. Go up here and push that button. And it will tell you if it's a happy camper. Okay? If it exhibits unhappiness, we'll see soon enough how to debug it. I'm going to mistype something so that you can see a mark of any logic when it's unhappy. You could see how it indicates its displeasure. Are you ready? Okay, so I'm going to delete the M here. I'm going to mistype it, okay? I'm going to go try to build it. And you'll notice it says model built with errors. And it has this problems view. It says the method unifor is undefined. So it's telling me, I don't know what you mean. I don't know about something called uniform. Now, the first rule with this is don't panic. The second rule is there's lots of things to help you. So one of the most important things is the message here. And if you can't see all of the message, if it's eclipsed by virtue of your size, you can drag this around. Sometimes it's even too big. You can right-click on it and do copy, and then paste it into a separate application. Here we go. Here we go. I'm going to paste it in here, and there it is. It'll actually tell me the message in its full extent. But ladies and gentlemen, more than that, I can double-click on this. And it will actually bring me, in most cases, it will bring me to where the problem is. Bring me to where the problem is, and I'll say, oh, there's a forgotten M. You notice it also puts right there, it's telling me, reminding me what the message is here. It shows a little X, a red X, ladies and gentlemen. Not the X of Switzerland, but a diagonal X. Okay, and let's now press this build button, and now it is a happy camper. It says build completed successfully. Okay? I've just caused and just fixed a first problem, which I almost guarantee will not be the last of this event. Okay, so now let's run this model, if we may. There we are, and at first blush, it seems unchanged. But let's go down to level of population. You'll notice that individuals now in the population are associated with ages. Do you see that? Can actually go click here. I'm going through each person in the population, enumerating them, and their age is changing. See or not? Yeah? Do you see that? No? Okay. Winchell, would you mind helping over here? Okay. Okay, so who else needs TA help? TA? Okay, so who would like me to show something? Would you like me to show you something that I did and you didn't catch? So again, we have age here. We have the population. For that population, age is drawn from this distribution. Everyone is it's a person, so they have an age, but here we're specifying what the value is in that population. And ladies and gentlemen, here we go. So people in this population are drawn from this age group. Okay? Yes, question.
What does it mean uniform? It means all the same.
It's a uniform continuous distribution. So it is associated with its probability density function is a constant between 0 and 100. And so it's equally likely to fall into any given your age interval, 0 to
Like a
1.
normal
1 to 2.
distribution on the statistics.
Well, normal would be an alternative. We could draw it from a normal, though it would be a truncated because it can't be negative. Or we could draw it from a log normal. This is from a uniform, which means that in any, someone's equally likely to be between ages 0 and 1 as they are between 20 and 21, as they are between 99 and 100, okay? Let's vary that, though, because you asked that. Let's try this. I would like to go to palette again, and I would like to drag in something that's different. May I do that? Okay. Ladies and gentlemen, I'd like to drag in a custom distribution. From the palette, under the Da Vincian emblem, I'm going to drag in an age distribution. Do you see that? Age distribution. It's marked under custom distribution. Who needs TA help? The TAs are ready for deployment. Okay? Okay, ladies and gentlemen. Okay, so for the age distribution, this is a way of specifying an empirically grounded distribution. A custom distribution that we craft. Yes, we can use, I probably should have shown, I'll switch back for a second to population pursuant to Roberto's question here. Ladies and gentlemen, if we had gone here, we could actually go up to this probability distribution chooser. If you put your cursor here, it has to be at a place you can insert a bit of code. Up here, there's a thing with a J and a magic wand above that. Do you see that? Yeah? Okay, I'd like you to click that. Oh my God. Oh, great. Okay, so my comment on that is mumble, but if you do that, you should be able to see a distribution chooser. Do you see that? Push on the J. Do you see something more pleasant than what greets me? Yes, that's because I'm using AnyLogic on a platform called Linux. Okay, so ladies and gentlemen, if you click on this, you should see a probability chooser. See or not? Yep. Yeah, and from that probability chooser, you have access to dozens of distributions, parametric distributions. But our goal here is a non-parametric distribution. It's one that we're going to specify as an empirical distribution. Okay? So we'll go from there over back to the age distribution. Okay? So you have access to dozens of parametric distributions. Beta, gamma, Weibull, normal, log normal. The list goes on. But here, ladies and gentlemen, we're going to specify a custom one. So for this one here, this is going to be a continuous distribution. And we are going to specify it, ladies and gentlemen, in ranges. You notice you could specify frequency tables, the frequency of certain observations, observed samples. We just get it to resample from these, or ranges. We're going to do ranges. And we're going to do it between 0 and 20, and we're going to specify the sort of relative frequency of this. Perhaps, we have 100 points between 0 and 20, between 20 and 40. This is continuous, so the probability that it actually hits at an exact endpoint is infinitesimal. Maybe we'll do 85 between, that's actually a striking decrease, but that's okay. 40 to 60, maybe, 40 to 50, let's say. I'll show that it doesn't have to be a uniform spacing. It is 80. Between 50 and 60, it is 75. Between 60 and 70, it is perhaps 70. And between 70 and 100, we have a number of observations of perhaps 60. Okay, there we are. Now, if we scroll down, we can actually see a preview of this distribution. And you'll notice the gradient reflective of the decreasing values here. So we have a higher density of the probability density in these regions. It slowly decreases. And for these last, from 70 to 100, it's approximately the same density. Okay? So this is a probability density because it's a continuous thing. We're drawing a continuous number from this distribution. And so this is basically telling us, if we consider small intervals, what's the likelihood of falling in that small interval divided by the size of the interval. Okay. So here we go, ladies and gentlemen. This is a continuous distribution that's going to be drawn from which this is going to draw. Are people okay with that? Notice this, that I've labeled mine age distribution. Okay. Okay, ladies and gentlemen, who would need TA help? Okay, great. So the next thing we have to do, we specified our age distribution, but we haven't yet used it. In order to use it, I'd like you to go to the age of the population, and I'd like you to draw from the age distribution. The way we're going to do this is we're going to call it. We're going to say age distribution, begin paren, end paren. Ladies and gentlemen, this begin end paren, it's not a pathology. It reflects the fact that we're making use of it. We're asking it to do some work for us. You may remember from high school using a sine function. You wrote sine of, well, depending on the conventions used in your class, sine of pi or radians or sine of 90 degrees or what have you. Remember that? And you put parentheses around the sine of 90 degrees, you put the 90 in the parentheses. 90 was the information it needed to do its job, the sine function. It needed an angle, right? Or if you did arctan, you had two numbers perhaps. But ladies and gentlemen, here, for age distribution, it doesn't need, we're asking it to do a job, but it doesn't need any information to do it. It's got all the information it needs already. So we put begin paren, end paren. Okay? That says, hey, do your job. If we left that out, it would just be naming the age distribution. It's like giving it the whole distribution for age. And we'll say, I don't know what to do with the distribution. Here we're asking age distribution. We're calling it, it'll give us a number. We're calling it, we're requesting it to do its job. It gives us back a number. Okay? So, ladies and gentlemen, that's age. So let's build this model up here. Build early, build often. Run early, ladies and gentlemen. Run often. You'll notice our model's being built up over time. There's now a custom distributions area, which includes the age distribution. Sometimes we will navigate to that. And I'd like to run this model now. Here we go. And now, ladies and gentlemen, we will see, if we go down to the level of an individual, that this model is recommended by more youths. Here we have younger individuals in greater profusion than was previously experienced. Ladies and gentlemen, a custom distribution. A custom distribution. Okay. Next, I'm going to do something that will further enliven your experience, if I could be so bold as to suggest it. I'd like you to go to person, and I'd like you to select the icon here. I'd like you to select this element there, and you'll notice that the oval has properties. When did we adjust one of those properties?
Radius.
Yeah, we did the radius. We're going to go back to radius, and we're not going to enter a number here. In fact, we're going to have it depend on a characteristic of the person. Does anyone want to guess what characteristic? Indeed. Now, the trick is that you can't do this directly, and there's a reason why. And you have to understand the semiotics involved. You notice it says equals here. It's expecting a number. If I were to, I'm not going to ask you to do this, just bear with me. If I were to start to type age, it's going to say invalid number. It's not going to be happy. But don't let that fool you. It doesn't mean it won't accept a non-number here in general. It just means we have to go frob this setting here. Or at least fiddle with it. So we have to go to dynamic value. And now it's going to let us type something in that could be a general formula, a general rule for computing it. And we're going to type in age. Now, as we'll see, this will lead to aesthetically displeasurable results. But bear with me. Age. Okay? Are we okay with that? So now we're saying the radius of their oval will depend on their age. Can we try this? Try or not? Try. Okay, thank you. Okay. Okay. The results are interesting, if not fully aesthetically satisfying. Right? In fact, some might call them downright distressing from an appearance standpoint. But they have some value to them. Let's go back to that oval and let's put in something more judiciously chosen, shall we not? Let's put in Jeff is, I'm not sure how Jeff avoids a smile at certain of these actions. Okay, perhaps it's because he's heard these things dozens of times previously. Okay, so let's put in log of 1.0 plus age. I do 1.0 plus age. Why am I doing that? Yeah, I don't get a negative if it's close to 0. I always want it to be positive. Okay? And then let's multiply that times 5. 5.0. Are we ready? I went back to the oval. I scrolled down to radius. You'll notice now we have this kind of indication it's dynamically computed. And I set it to be 1.0 plus age. The log of 1.0 plus age quantity times 5.0. I'm going to build it, make sure it's happy. Are we okay with that? Let's run it then. What will we see now? There we see. What lies before us? What lies before us, ladies and gentlemen? Well, notice with people of different ages, their ovals are of different sizes. A Methuselah will be associated with a larger radius. A child with a smaller one. Okay, and we have that encoded visually. You could see where the young children are at the same time, the more senior members of the population. Okay? Visual depiction. Ladies and gentlemen, you will see visual depictions coming up again and again. When I was in my youth, I thought these were eye candy and not particularly deep in their significance. But when it comes to communication, when it comes to even spotting issues with your model, when it comes to getting a feeling for what's going on in the model, actually visualizations are important. They're not merely niceties. They actually can help clue us in to where there's inconsistencies between what the model is showing and what evidence is known to suggest. Let me highlight something else for you that again is pursuant to Kim's question that bedeviled us before lunch. That wasn't quite the right word that we grappled with before lunch. Ladies and gentlemen, a truth of the situation is this, and it took me decades perhaps with models before it fully dawned on me. Jeff may have realized it before I was even born. Well, it's true. He didn't get that beard from nowhere. He's fought the hard fight for many more years than I, and done well by it. Ladies and gentlemen, often knowledge doesn't come out from stakeholders, from people who participate in a system, from the experts, until you actually show them a running model. You know, there's a nice, neat plan that we have. We elicit knowledge from our stakeholders, from the people in the system, those who are experts in different areas, and we build this model which incorporates that knowledge, and then we run it and derive insights. But it's not that neat in the real world. A lot of the time, the knowledge of individuals, the relevant knowledge, is tacit. It's there, but it's not verbally articulated. And people don't reflect on it fully until they see something from the model that reminds them of their experiences or their observations. And seeing the model yield results, seeing particularly results over time, often that elicits feedback from individuals you wouldn't have obtained otherwise. It taps into observations like, oh yeah, I used to see patterns like that, but we haven't in recent years because we changed how this process in the ER worked. Or someone will say, well, that's very realistic. That's just what we see. I remember going through this with clinicians before, and a clinician commenting, yeah, I never told you, but that was one of our findings from that study we did several years ago. So the model actually predicted this thing that he would never have anticipated, and that jived with his experience. And it wasn't until he actually interacted with the model and could observe the results that tacit knowledge, unstated, previously unspecified, would emerge. And so that neat division between evidence gathering, model building, model use is actually, it's a convenient sort of way of broadly thinking about it, but in fact it breaks down, because often it's the model use that elicits the information. And it's a self-driving cycle where it helps elicit the information from stakeholders, perhaps because of enhanced buy-in, perhaps because it reminds them of things, and that feeds forward to a better model, a refined model. So pursuant to Kim's question, sometimes getting the model in front of people, as incomplete as it is, helps elicit knowledge in ways that otherwise wouldn't have been possible. Odd fact of humans, but a notable feature. Okay, ladies and gentlemen, so we have a little model. A question? Is there a question? Yes.
I wanted to find out.
Yes.
So when we are typing, do we always have to put 1.0, or you can just put 1? Do you have to put 1 decimal place always?
So I do this for. So thank you for asking. Thank you very much for asking that question, and it's a good question. I will tell you two seemingly contradictory facts, but I will reconcile them. The answer is, do you have to type 1.0? No, you could type 1. At the same time, it's dangerous not to type 1.0 for beginners. Let me reconcile those facts. So, in most cases, typing 1 and 1.0 will yield no changes, no difference between them. Most cases, you'll be fine. But there are certain expressions where it will be disastrous. Let me show you an example, if I may. Okay? So I'm going to go to this population, and I am going to put in, by the way, you notice AnyLogic has some puzzling features. You notice if I double click here on population, it shows it as having selected population here, but it's actually still showing me mains properties. This is a notable issue in AnyLogic. So sometimes I have to sort of click away and then click on it to finally get it to select. Okay, so this is the deal. If you were to type, 1 plus 2 for the X location, it will interpret it as 3.0. It'll actually execute it as 1 plus 2 as integers, which will be 3, and it will convert it over to a floating point number to convert it to their X location, okay? Perfectly fine. If I were to do 3 times 2. It'll multiply 3 as an integer times 2 as an integer, get 6, and it will convert it over to be a floating point number and get 6.0. Fine, no difference from doing 3.0 times 2.0, right? No difference. So you might say, well, why does it ever matter? Because, ladies and gentlemen, if I write this, that will divide 1 as an integer by 100 as an integer and get 0. And it will convert 0 to a double number as 0. Integer division, 100 goes 0 times into 1. It will actually perform that as an integer division. If I do 1 over 2, the result will be 0, because it will divide 1. It will ask, how many times does 2 go into 1 as an integer? 0 times. So the result of this is 0, and that's the equivalent of specifying 0.0. So the reason I do this is because my students, about once a boot camp, my students who do not do that make a mistake, and they get a bug they can't figure out often without help. And it's all because of a dumb thing that this is not the same as this. And so I just, as a routine, I have them type the 0.0 so that they don't run afoul of that. And it helps head off that bug. So as a general rule, it doesn't hurt to put the 0 in, and it helps head off a class of errors that can be maddening, because you see something that looks so clearly correct but is interpreted in a horrible way. It's interpreted as 1 divided by 2 as an integer, which is 0. Okay, so that's why I do that. For my more advanced students, the Winchells of the world, for example, he knows when to put those in. I know when to put those in. But I don't like to suggest that other people fool with it, because it can lead to maddening bugs that are painful to experience. So you can choose your route. If you can remember to do it with division, power to you. Otherwise, just put it in always, you'll be fine. Okay? Yeah. Okay. So, ladies and gentlemen, here we have a model where we have visual representation, we have heterogeneity, different ages, different visual representations of these things. Let us, ladies and gentlemen, press our advantage, though, because this is not yet a truly dynamic model. Eh? What's missing from here? Time, indeed. Time. And time confronts even us. We have 45 minutes left, and I'm going to cut to the chase. I had lots of steps in between, but we're going to introduce some dynamics. And the mechanism of introducing these dynamics is one of several supported by any logic. We have state charts, we have events, we have stocks and flow diagrams, we have dynamics associated with progression along workflows and discrete event modeling. But today, we're going to avail ourselves of the first, state charts. So I'd like you to go to person. Go to person and go to the palette. Would anyone mind getting me a bit of tea? Thanks very much.
Can you have it black? Sugar?
No, nothing at it. Yeah, just as raw as it can. Thanks. Thanks very much. Okay, so ladies and gentlemen, so we're going to go to person, and we're going to add to person a state chart. Now, a state chart represents three things. It bundles them together, these three different things. Do you remember my parties? This notion that when we think about describing a model, we think about, for the agents, what are the properties associated with them? Another component we ask about is what are the actions? Remember that? What are the rules governing those actions? Under what conditions do those changes, the actions, actually take place? Those are the rules. We also had time, the T, interventions, the I. We had environment, the E. But then we had S, which is the state. Remember that? The current state that they're in. State, which is changing characteristic of them in contrast to properties. So we're going to here add a state chart, and that's going to capture, ladies and gentlemen, the state, the S, the state of the state chart, yes, but also the actions, in as far as transitions, and the rules governing those actions. So let us introduce this, if we may. Okay, so I'm going to go state chart entry point. And I'm going to enter, this is going to be smoking state chart. Okay? Alas, I accidentally forsook the microphone today, and my throat is taking its revenge. Testing. Okay, we'll see if this eases the pain. Okay, smoking state chart, ladies and gentlemen. Let's drag a state in, and this is going to be never smoking. How did I do that? Let me go rehearse that again, because it's easy to miss. I'm going to delete that for those who have not followed along, and I'm going to drag in. Do you see it's under agent, state chart entry point? Alternatively, we could go down to the agent palette. But otherwise, it's under, to the state chart palette. We could go either there or from agent. So let's drag into this. It's smoking state chart, right? And then I dragged in state. And this is going to be never smoking. Okay, so never smoking. And next, I'm going to drag in, probably I should have called it never smoker. I stand corrected. Thanks so much. Current smoker, and thanks greatly. Former smoker. And I'll change this to never smoker. Sorry, I misspoke. Thanks greatly. Oh, okay.
It's hot.
Fell short. It fell a centimeter short of disaster. 2 centimeters. Okay. Okay, ladies and gentlemen. So never smoker. Let me go. Never smoker, current smoker, and former smoker. I made the mistake of enlarging this. I should have retained this. So here are our states. These are the possible states a person could be in with respect to smoking. As we'll see in general, we may have more than one state chart. And now I'd like to drag in a transition between these states. So there's going to be a transition from never smoker to current smoker. And with what behavior will that transition be accompanied? What do we use to describe a situation where someone goes from a never smoker to a current smoker? What would we use to describe that? Initiation is one word, uptake is another. Initiation seems to have prevalence in the tobacco world, so I'll call it initiation. And you'll notice that I can click on that transition and call it initiation. But more than that, I can select whether or not to show the name. And in general, I like to show the name because for stakeholder understanding and modeler reflection, it can be good to show the name. Initiation of smoking, ladies and gentlemen. Okay, next, I'd like you to drag in a transition from current smoker to former smoker. Ladies and gentlemen, what behavior would be associated with that? What might we call it informally? Cessation or quitting. So we'll call it cessation. Show name. Ladies and gentlemen, we described the states in which a person could be with respect to smoking. And now what are we describing? From the standpoint of parties, what are we describing? The actions, ladies and gentlemen. Actions. Okay. Okay. Next, we're going to drag in, and here we have to do a little bit of a flipsy. So we'll flip it around. there it goes. So what is this? What action does that represent? Relapse, ladies and gentlemen. Relapse. Okay. So you notice by showing the name, then we can click on the name and drag it. Do you see that? Okay, thanks. Thanks. Ladies and gentlemen. Okay. So now we have a theory of smoking transitions. Now there's one thing that I've left unspecified of the three things that state charts bring. Remember I said state charts pack into one description three types of information from parties. What are those? The states, yes. The actions, yes. But what's the third? Rules, indeed. And you'll notice that associated with each of these is a rule. And you notice it says timeout. Timeout for 1 year. Cessation, timeout. That's just the default rule, okay? We'll come back to this in just a second. I want us to see visually the implications of that rule. It'll help bring home the significance of that rule and some of the meaning of the timeout. Are we okay? So we'll come back to that. It won't be our final rule, but it will be a useful point for learning. Okay, ladies and gentlemen, I'd like you to run the model. First, I'd like you to build it up here. Build early, build often. Ladies and gentlemen, run early, run often. So right-click on the simulation, and I'd like you to run it. Now, at first blush, you won't see anything different. Where would we go to see something different? Whither to go? Down to population, ladies and gentlemen. And here you'll see an individual engaged in what? Quitting and relapsing. And if we go to the next person up, we'll see a distressingly similar pattern. Do you see that? It's almost like there's no difference. No, you'll notice there's a certain amount of animation associated with this. This counts down the time until this anticipated next action goes. Do you see that? That's the time remaining. What is that? At what does that time start? If we, ladies and gentlemen, notice up here while we're running it, we can actually pause it. And actually we can run it forward for brief periods here. We can run for a certain number of time units. We can even run until the next sort of little bit of time here. And you'll notice that we'll run it along, okay? And now it's actually servicing different individuals. But we can run it along, and we'll see if we were to pause it again and run it along for, let's say, 0.1 time units. Here we go. 0.1. Hey, come on. 0.1 time units. I did this. I pulled down here and I filled in run for. Watch this. I'm going to run it for that. Run it again. Here we go. Notice it's going down by 0.1 years until the time. Now it's gone. And now it's 0.9 years till they relapse. Why 0.9? Because they fall back within how long? 1 year since they entered. Okay? But this is kind of a cumbersome interface to explore it. Let's add something which lends visual insight. Humans, remember I mentioned this notion in Macdonaldian parlance of a model as a learning prosthesis. And I argued that simulation complements our limitations in terms of reasoning quantitatively about complex systems. Ladies and gentlemen, one of the areas where humans excel is in visual parsing of complex patterns. We have exceptional visual cortex that allows us to sort of identify patterns visually that can be quite complex. Let's play to that strength instead of hiding it. So I'm going to give just a wee bit more animation that will allow us to appreciate additionally what's going on, if I may. Ladies and gentlemen, I'd like you to go to the palette, and I'd like you to go where you have never in this event gone before. I'd like you to go to the palette, to the agent area of the palette, and I'd like you to draw again a variable. And this variable will be called color. C-O-L-O-U-R, by the shared convention of the Queen's English. That was not intended. And I was not exclaiming on the color. On the color spelling. Okay. Ladies and gentlemen. Oh, thank you very much. Thanks. That's yeah. A reddened hand and a wizened sort of attitude. Okay. Great. Okay, ladies and gentlemen. Color. So we're going to have a variable that's going to change over time someone's color. This is going to be another aspect of their state. Thanks so much, Sharon. I'm sorry for the trouble. Someone kindly lent me. Okay, here we go. Okay, so ladies and gentlemen, color is going to encode another aspect of state. This is another way we characterize state. This is going to be more epiphenomenal state. It's just going to describe their color. It's not going to affect their evolution. It's more a reflection of their evolution. It's more of a kind of manifestation of the underlying thing rather than a governing factor. So this is going to be type other. And that other is going to be, confusingly, a designation of the set of all possible colors. Do you remember when I described the set of all possible people, or personhood? I said it came with a certain convention. What was that convention? When we denoted person as denoting personness or personhood, we used a capital. And so it is with colors. When we're denoting colorhood or colorness, set of all possible colors, we use a capital C. But we also, ladies and gentlemen, submit to the ever more distressing power of the American imperium. Okay? We type C-O-L-O-R. Okay? Capital C-O-L-O-R. Okay? Perhaps in another year, if trends continue as they may. This may be due not to the results of the American Imperium, but the California Imperium. But we won't go there right now. Okay, so capital C-O-L-O-R. That's something built in as part of Java libraries. It's how we designate color. And basically this is going to denote one of those colors, just like people in the population are one of the types of things can be depicted as person. It's personhood. So here we have color, and by default its initial value is going to be black. Okay? Yeah. Black. Ladies and gentlemen. Okay, next we go up here to this designation there, oval. And guess what we're going to do on that oval? We're going to set it so that its color is set by that variable. Now, how did we do it with radius? How did we change it from being a fixed number to actually being something that we could give an expression for it? We could give a formula for it. How did we do that? Sorry?
We used dynamic value.
Yeah, we used a dynamic value. We engaged in frobbing behavior of this little thing here. So we changed this to be dynamic value. And then we can actually specify a rule. So instead of having just a fixed number or fixed color, we'll actually go to fill color. We'll choose dynamic value, and we'll put in the name of the variable with a refreshingly appropriate spelling. Okay? Okay. Color. Do you see that? So if we were to run this model right now, what color would people be? They'd all be black color. So let's run that and verify that. Make sure it's running. And ladies and gentlemen, it's actually really good practice to run a model as you add things, because it spots as soon as possible if there's an issue. And you know if there is an issue, you can track it down to a very small number of changes, because you've only made a few changes since the last time you built it, the last time you ran it. So here we are with black color. Do people understand why that is? It's because the default value, the initial value for color was black. Do you see that? Okay, ladies and gentlemen, now we're going to go one step further, and I'm going to expand your horizons. I'm going to perhaps press your limits. Okay? I'd like you to go to Never Smoker as a state. And in Never Smoker, ladies and gentlemen, you'll notice if we select it in properties, we can ask it to do things when we come into the state or leave the state. These are called entry actions or exit actions. Do you see those? So I'd like you to do the following. I'd like to set color to be a certain value. Okay? Now, I wish we could just do it by choosing color here. I'm going to set Never Smoker to be lime green, current smoker, ladies and gentlemen, to be red, and former smoker I will set to be magenta. Okay? But it turns out that doesn't do anything for the visual appearance. If we were to run the model just now, we would see nothing different than before. It's distressing because it seems so obvious that they should change color, but alas, AnyLogic understands not our coloration desires from that. Instead, we need to be more explicit. Instead, we need to be programmatic. Instead, ladies and gentlemen, you need to code. But don't worry, you've already been coding. Ladies and gentlemen, you're already Java programmers. I smuggled it in. I smuggled it in, ladies and gentlemen, in this log expression. I smuggled it into main in drawing people's locations from distributions. I smuggled it in this call to the age distribution. Ladies and gentlemen, you've already been initiated into the conclave of Java programmers, and now you will reap its power. Okay? So, the entry action to Never Smoker. I would like to set color to be a value. I'm going to set color equals lime. Lime, ladies and gentlemen. Next, for current smoker. Oh, by the way, notice I did something that may puzzle you. I put in a semicolon after that. Do you see that? Do you see the semicolon? Ladies and gentlemen, if I had my druthers, we wouldn't be using Java for this program. I told AnyLogic 4 years ago they should offer another option. They haven't done it yet, and I guess they maybe never will. Yes?
Do you need the space between color?
No. I put the space in. Thank you very much. Java ignores white space in general, as long as you have one white space. Excuse me. If you have two words next to each other, it needs at least one white space to distinguish them. Here, between color and equals, you can leave out the white space and be perfectly happy. Okay? But the thing that does matter is the semicolon. Ladies and gentlemen, let me give you a rule, because students often get confused. When do I need a semicolon? The rule is actually a simple one. If you follow it through, it's a powerful rule. If you're telling AnyLogic a value to use, you're just specifying a value to use for something. For example, the oval up here. If we're just specifying what radius to use here, or if we're specifying what color to use for fill here. If we are specifying a thing to use for age, or up here, the value to use for the X and Y position. We're just specifying how to compute a value. It's kind of a formula. You don't need semicolons for that. It's computing a value. It doesn't need a semicolon, okay? Where you do need semicolons is where you're telling it, do something, make a change, make this happen, perform this action. And that's what we're doing in the actions. So we need a semicolon after that. We're telling it, do this. Assign this variable, make that variable equal to this color. We're not just giving it, we're not just saying line and having it use line. We're saying make this variable equal to line. So there, whenever we do that, it's called a statement. And you could think of this almost like an exclamation point. Make it happen. Okay? Boom. And Java is unfortunately afflicted by cancer of the semicolon. Okay? A more modern language like Scala would be unencumbered by such needless cruft. Okay, so ladies and gentlemen, under line, under this entry action for never smoker, color equals line. Under current smoker, color equals red. Under former smoker, color equals what, ladies and gentlemen? Magenta. I learned what it was from one of my students a few years ago. After that, I liked it. Yeah. I still haven't figured out mauve and fuchsia. Sorry? Teal. Taupe. Yeah. Okay, ladies and gentlemen. When I was at MIT, we had a hacker dictionary, and it's still extant. Eric Raymond codified it later. And one of the definitions of nerd is someone who's interested in everything in the world except how to dress. I must say I follow that pretty well. Okay, ladies and gentlemen, if you go up to simulation and you run it, we should have built it, but we'll go run it. Here what we see. What do we see before us? What do we see before us? What's going on here?
We're at a ride.
Sorry?
We're at a ride.
Okay, I'm innocent of that, but it's exhibiting sort of pulsed behavior, lockstep behavior. Why is it exhibiting lockstep behavior? It's because everyone is changing from one state to the next at a fixed time. Do you see that? It's because we have a fixed timeout. Now, timeouts don't have to be fixed. We could actually draw the time from a distribution. We'll come back to that later. How long they stay never a smoker, we could actually draw from a distribution. But ladies and gentlemen, it's often more pleasant and more satisfying and more biostatistically grounded to draw that to actually characterize it not in terms of how a residence time drawn from a distribution, but in terms of a hazard rate, a chance per unit time of going from one to the next. So I'd like to put in place a different type of rule. Remember I told you, within these state charts, they bundle together states, actions, and rules. And the rule right now we have is very simple. It's if you're in this never smoker state in exactly one year, you go to this next state. That's a very simple rule that governs when that takes place. After you come in here, 1 year later you leave. Similarly, for going to cessation and relapse. And that's why they're all pulsing in that most highly sort of correlated fashion, like fireflies upon Malaysian rivers. So, ladies and gentlemen, I'd like to now retain this idea of specifying rules. I'd like to change this from a timeout to a rate. And here, we're going to specify a rate of 0.01 per year. Now, what does this rate mean? Well, it's a hazard rate, ladies and gentlemen. It means that the residence time in the state here, given that this is the only output, the residence time in the state is exponentially distributed for those room that makes sense. It's a memoryless process. No matter how long you've been here, you have that same chance per unit time, 0.1 at Winchell, 0.01 per year of leaving. You have the same kick of the can every, on an ongoing basis, and it's actually continuous. And so the chance of remaining in this state decreases for those who are quantitatively minded about it. The probability of remaining there goes down as e to the minus 0.01 times the time that they spent there. No matter how long they've been there, over the next year, they have the same chance per unit time of 0.01 that applies, no matter how long they spent there. And that's a memoryless process. The average time in that state, as a factoid, if you have an exponential distribution, the average time in the state is 1 divided by the rate, which is 1 divided by 0.01 or 100 years average. So let's put that into place. What do you think will happen now if we run this model?
Is that for the never smoke stuff?
Never to current. Yeah. Never to current. Yeah. Okay, who needs TA help?
TA has something to say.
Okay, speak on.
So, try to use control space. Try to use control space a lot. Just keep trying to use that.
Excellent.
A lot of people are running into problem with color. That color, the COUR, and I don't know if Nate is just setting everyone else for this as an example.
Control space.
But a
Yeah.
lot of people I see is either they name the variable
Good.
COLOR and then they try to use it.
Yeah.
Try to use the other spelling to refer to that. So try
Yeah.
to use it to do that.
Yeah. Thank you. I appreciate
Just
that,
keep
and
doing that.
I probably should exercise less challenge to the conventions of the American Imperial.
It's good. So people realize
Yeah, and-
why it can be.
Yeah, that's good. And Turnbull tried to stand up to it. Might as well do our part. Okay, so ladies and gentlemen, let's run this model, if we may. What do you think we'll see now? Well, now we've changed it so it's not a fixed time. It's actually a chance per unit time that they'll leave. Do you think they'll all be synchronized? No. No, ladies and gentlemen. Here we see individuals. Why do we see this pattern? What's going on? Softly pulsing. What's going on here? Well, they're going at different times. They have a certain chance per unit time of moving of 0.01 per year. But once they've moved over, then, ladies and gentlemen, they're fluctuating at a very fixed rate. Do you see that? They're kind of engaged in regular pulsating behavior after that. But they're not synchronized with each other because they came over at different times, and they're leaving each 1 year afterwards, but they're not in sync. But they're pulsing at the same rate. Do you see that? See or not? See. Okay, good. Ladies and gentlemen, let's continue the thought. Next, cessation. Ladies and gentlemen, cessation. We will change that to a hazard rate as well, to a hazard of 2.0 per year. It's a very sad thing, ladies and gentlemen. If you look at the record on smokers, particularly later in life, there's a lot of quitting attempts which occur. But sadly, those quitting attempts are often short-lived. You know, there's such a physical pull of the addiction back, and there's so many social pressures. Your friends are also smokers. So many stresses which draw someone back to this as a bit of comfort. It's a hard thing to stay quit, but people quit often multiple times a year. But sadly, relapse, ladies and gentlemen, relapse is going to pull them at a high level. So I'll change relapse to be 4.0. Excuse me, it's not a timeout. I stand corrected. It's a rate of 4.0 per year. What does that mean? It's not a probability. It's a probability per unit time. It's a density. So what does that mean? A hazard rate of 4.0. Well, here it means that on average, a former smoker will spend 1/4 of a year, 3 months, 1 over 4.0 of a year, 1/4 of a year, or 3 months before relapsing on average. That's what that means. Okay, they fall back with very high frequency. Now, right now, we're representing it as memoryless. Doesn't matter how long they've been quit; they have that same chance per day, per month, per year of falling back into smoking. As we'll see, we can change that very readily and have their chance of relapse lessen, their monthly chance of relapse lessen the longer they've stayed quit. That would be very hard to do in an aggregate model. But here, in an individual level, we have recourse to keeping track of how long they've been quit and to varying that rate accordingly. Ladies and gentlemen, here we go. So here we have this model. We see them engaged in quitting and cessation behavior. A given individual here may be flipping back and forth between state charts. Oh, it's now finished, so we're not going to be able to see the dynamics here. Let's slow this down. I'll go down to level of a particular individual. We'll find an individual who's in a smoking-related state. Here we are as a former smoker. And we'll see them moving back and forth between these things with the accompanying change in color. Here's their little depiction there. Ladies and gentlemen, a depiction of dynamics here with fixed rates. May I take this further? Should we put in age-specific rates for initiation? We know that in many societies, I think probably all, it's fair to say worldwide, that are afflicted by smoking, that initiation behavior is age mediated. It differs in different subcommunities. In the U.S., for example, in subcommunities of Caucasians, it's often younger, so sometimes as early as 10 or 11, and it varies in early teens to mid-teens. In African Americans, it often occurs much later, 18 to 21, something along those lines, at a later stage of reaching age of majority, often. But let's try characterizing by age here. So what we're going to do is we're going to pull in from this, ladies and gentlemen, a hazard rate that's going to vary over age, okay, for this individual, that will dictate their likelihood of progression. And I have my eye on the time. So I'm going to pull in what's called a table function, okay? And I'm going to say initiation hazard by age. Meaning we're going to specify for a given age group what the hazard rate is for initiating smoking. Are we okay with that? Now we have to be a little bit, I want to reflect back here what we're doing. Here we're going to be hard coding initiation rate by age. That'll be a good little exercise. But in an actual model of smoking behavior, in many cases we won't actually want to hard code this. This should be an emergent property resulting from other factors, maybe socialization patterns associated with peer pressure that result in this. And it might change under intervention regimes, right? The likelihood of initiating at a given age might change depending on anti-tobacco education, depending on efforts to stem the availability of tobacco in convenience stores. The ease of obtaining tobacco might actually change this. We're going to specify it as fixed, but please have a chance to reflect on, that may be appropriate for some models, having an exogenous specification, but in other models we may wish to make it endogenous. So ladies and gentlemen, I dragged in from table function, and over here in the table function, I would like to go, and we're going to enter in some values here, okay? So in argument 0.0, we're going to have 0.0, no initiation in the youngest ages. 10.0, it's going to go also to 0. And then we're going to start to rise. 11.0, 0.005 per year. So roughly speaking, 0.5% per year. 12, 0.0075. Ladies and gentlemen. 14, 0.01. Ladies and gentlemen, 15, 0.015. I'm doing this in great detail in the teenage years because in many communities those are associated with high rates of uptake. Okay, 17, and now we've sort of posited 16 as the year of highest risk, and now it's going to go down again. So 17, 0.075, 18, 0.015, and we'll drag down this a little bit, and 19, 0.01. Soon it will get closer. I'll use this plus. Oh my gosh. Okay, with this plus, I'm going to enter 20, and this is going to be 0.0075. And I'd like to move this down. There's a way to do it. I'm surprised that these things are right now grayed out. Here we go. I can go down here and move up. Boom. There we go. So here we go. And next I'm going to enter 22. And it's going to be 0.005. And now that we're past the high-risk years of youth, we're going to enter 25, 0.0025. We're almost done, ladies and gentlemen. We're going to be passing the youngest years here. Next 35, it's going to be 0.001. And 40, we're going to assume that it is 0.0. Now, some of you may have entered these things in a different order. You know, one appears above the other or what have you. You can actually go and select them and move them around with this. Move up or move down. Okay? So, ladies and gentlemen, I've just entered this, and I'm going to say, if a person is 100 years old, we're going to go and also say 0. Okay? You'll notice there's a little graph of this. Do you see that? Do you see that graph? Okay. Good. Okay. We're coming in for a soft landing, but we have a bit more work to do. Before the day is out. Ladies and gentlemen, here's our hazard rate function there. You notice up here, if it says out of range, trigger an error, I'm just going to say nearest. So if someone's more than 100, we'll treat them as having a rate associated with 100, which is 0. Okay? We actually could eliminate the 100. We don't even need that because 40 is also 0. So I'll eliminate the 100 there. Just 40 is the last one. Okay? And that will make it easier to see the texture of the graph. Do you see that? Great. Okay. So there's just a little bit more of frobbing in which we must engage. Okay? So, ladies and gentlemen, let us frob away. Okay. I'm going to do something, and you're going to tell me what's wrong with it. Okay? I'm going to put in for initiation here, initiation hazard. Instead of saying it's 0.01 per year, I'm going to say it's initiation hazard by age, and I'm going to look up their age. Okay? Now, don't type it. Don't type it, ladies and gentlemen. Do initiation control space. and just pick initiating hazard by age. And you notice it even tells you it needs something to be passed to it to do its job. What does it need? It needs age. It needs to tell it what to look up. After all, it's a thing that looks up a value and gives you the appropriate value to use. So initiation hazard by age, and we'll give it age. That's what it needs to do its job. It's the value it's looking up along here. That's its so-called argument, and it will find the appropriate value and return it. And if it falls in between, if we give it 13, it will be halfway in between these, it will linearly interpolate. Okay, here we go. There we have it by age. Do you see that? Initiation hazard by age, and we gave it the age. Here, let's go over here. There we go. Just like that. Do you see that? Okay. First of all, can we build this thing? Okay, let's build it, and it looks like a happy camper for me. Who needs TA help? Okay, now let's run it. If yours builds okay, let's run. Ladies and gentlemen, what's going on here?
Only the kids are smokers.
Sorry?
Only the young people are smokers.
That's right. That's right. So only the young people smoke. We could run this for a nice long time, and only those ever start. Why is that? Their ages aren't changing, ladies and gentlemen. Right now they have fixed ages. If I may use a bit of the terminology we used earlier in the day, here age is static, but more than that, more deeply than that, it's what? Is that an endogenous variable, an exogenous, or an ignored? It is exogenous. Okay? It's exogenous. We're specifying some characteristics. We're imposing them on the model. Where? Wherein lies our specification? It's drawing it from an age distribution. Now that's all fine and good, but we want to turn it, it was fine for our initial purposes, but we want to turn it into something that's changing over time, do we not?
Yeah.
Something where we see them age, this cohort that we've depicted. Tomorrow we'll have an open cohort. Well, groups coming in, being born, and so on. But for now, we'll just have them age in place. Is that okay? Okay, ladies and gentlemen, we're getting close here, very close. It's a little bit of time lies between us and a much more dynamic model. So, I'd like you to do something. We're going to convert this specification to something different. I'd like you to go, see where it says age. I could do this in two ways, and I'm contemplating in which to engage. I think we'll do it one way. We can do it later in the boot camp. We'll see another. We'll call this initial age. So instead of talking about it as their age, it's the age in which they were created in the model. When they started the model, what age were they? Does that make sense? Okay, so we're going to say initial age. And ladies and gentlemen, notice when we type that, there's a little light bulb there. Okay? And it says press Control Enter to refactor. So I'd like to actually press re-enter, and it will actually go through the model and find all cases where that's referred to and let us automatically change them. So we'll say OK. And now we've updated the model accordingly. It's actually changed it so that where it's referred to, it now refers to that updated variable name. If you didn't get a chance to do that, Winchell or Annie could help you. Okay, ladies and gentlemen, we're getting close. We're at the cusp of, if not greatness, at least goodness. Okay, don't worry, I'm not going to promise to make you great again. Okay, ladies and gentlemen, here we go. Let's go here, and we're going to drag in something. These are the words you dread. that we've never seen before. Okay? We're going to go drag in from the agent palette with the Da Vincian emblem, ladies and gentlemen, a function. And this function is going to be called current age. Current age. Okay? I dragged in a function, and this function is going to be something we're going to be able to ask, hey, what's my age? At any point, it will compute it for us. Are we okay with that? Okay. 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 Who else needs help? Okay. Current age. Now, mark my words. View my actions. Okay. Current age, we're going to do a couple things. It's going to be very quick, almost painless. The first thing we're going to do with current age is we're going to indicate what job this function has in life. Here we're going to tell it return a value. Its job in life is not just to perform an action, it's to return a value. It's going to calculate something, namely the current age. Is that okay? Ladies and gentlemen, returns a value.
Is for Mac also Control Enter or is it something?
Options, option space.
Oh, Mac command.
Oh, Control Enter. I don't.
Command enter.
Command Enter.
Okay. Command return, right?
Yeah.
Yeah, yeah. Don't worry, it's only referred to in two places, Annie. It's referred to up in the oval, and it's referred to here. Yeah. Okay. Okay. Okay, ladies and gentlemen. Okay, so we set it to return a value. Its job in life is to return a number, a value. Okay? So current age. Next, we're going to tell it what value to return. The value to return is going to be the following. Initial age, don't type it, ladies and gentlemen. Press Control space or Option space and choose initial age. You'll spare yourself from the TA risk of a mistake. Initial age plus the current time. So at the start of the model, time 0, their initial age, and however many years have elapsed, they're going to now be their initial age plus that amount of age. Are we okay with that? Ladies and gentlemen, now we have a way of obtaining their age. Let us repair ourselves and let us repair this oval size. We want this oval size to depend not on their initial age, but what? On their
Current age.
current age. Thank you. Okay, so where the oval is, we're going to say current age. And we're going to ask it to do its job. We need to call it with this begin paren, end paren. Okay, let's run this model and see what happens. So here we went to this oval and we said, let's do it by current age. So we replaced initial age by current age. Do you see that? Who needs TA help? The TAs stand ready. Okay? Ladies and gentlemen, here we go. Yes, with the oval. Okay, build early, build often. Make sure it builds okay. Flag a TA if it doesn't. Now let's run it. What should we see? What should we see now? Yeah, okay. So something is going on.
Yes.
But we still haven't yet obtained our full query, have we? Because what still has to be updated? Initiation, ladies and gentlemen. Because initiation just depends on the initial age. We're going to change that instead to depend on current age. Are we ready? Ladies and gentlemen, current age. So we want the initiation hazard to be computed for their current age, not just their initial age. So as they enter into the high-risk teenage years, they'll be more likely to initiate. As they leave those years, they'll be less likely to initiate. Thus far, it had been the same hazard rate all through, depending on their initial age. Now we need this to depend on current age. And you notice we need current age, beginparen, imparent, because we need the function to do its job. It doesn't need any information to do its job, so we have beginparen, imparent. Okay, who needs Wunschelian help? Okay. Ladies and gentlemen. Ladies and gentlemen. Okay, we're just about done. But I'd like to run this here, and we'll probably be spared a certain pathology, but we'll see it. Still, only a small number of people actually develop smoking. Why is that? After 100 years. Well, the people who develop smoking are those still who started in that age. It's actually not recomputing it actively. So finally, to recompute this thing, to get it to recompute it, we have to put in a little nod to the situation. Ladies and gentlemen, I'm going to put in a transition from this state to itself. And it's a little bit distressing that we have to do this, but it's a fact of life. Okay? So every 1 year, maybe we'll have it recalculate every 1 month, each person is going to reevaluate what their initiation hazard is. So this is going to be recalculate initiation hazard. Basically, ladies and gentlemen, without this, it comes into Never Smoker and figures out what this value is and uses it from now on. If we have this self loop, it'll actually recompute it. It'll re-enter it and recompute what this hazard rate is. I'm sorry to tell you about that, but that's the reality of the situation. Okay. I wish it.
What does this loop do?
This loop basically gets it to leave this state and come back in, and it's when coming into a state that it recalculates all the rates associated with the outgoing. Okay, so let's run this model. Let's run this model, ladies and gentlemen. Oh, okay, that's unexpected. Okay, we still have comparatively few people starting to smoke, actually. In some cases, it's very few indeed, because they pass through the teenage years unafflicted. But we do get some people often starting to smoke. But people are not subjected to the same hazard over time. Most of these are now mature individuals. Their current age is much older. In fact, they've not been subject to the predations of age in terms of mortality. But they passed through the teenage years and succeeded. So this is a model with age-specific hazard rates. Hazard rates which peak during teenage years and leave, and as they age, they initiate. Okay? So we stop at 5?
Yeah.
Okay, ladies and gentlemen, for you, the time is 10 past 5. For me, the clock reads 9 past midnight. We have some exciting things to go on. What I was about to do was to combine this with a state chart, very simple to add actually, of heart disease, and to have the likelihood of developing heart disease per year depend on what state they're in here. So that if someone is in a current smoker state, they have a much higher hazard rate of developing heart disease than a former smoker. And then adding in a piece, depending on how long they've been a smoker, how many pack years, for example, they might have smoked, or how long it increases the risk of heart disease. But that exercise lies to tomorrow, when you, and most certainly I, are in a fresher state. Okay? So I think we'll declare victory. We'll declare the mission accomplished, and we'll now pause for the evening. But I'm happy to answer questions. and I'll look forward to joining you tomorrow. I stand remiss in my jet-lagged state. I've forgotten to do one thing, and I have to apologize to all of you. I realized it partway through, but I failed to deliver on it. Here, ladies and gentlemen, I will close this model, and I will go post this model post-haste to the site here, so that you can go obtain it if you are so inclined. Here we go. And here it is, Smoking and Heart Disease Sydney. And now it is up on the site for your viewing pleasure. Okay, so you're welcome to go get it if you're so inclined. If there's anything that caught you up, if you want to see how I did something, please be encouraged to do so. With those comments, I will